Hello everybody, my name is Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site. And today I'm coming to you from Cranfield University and the Boeing 737-400. Okay, we'll be having a look first at the hydraulics on the 737, and we'll start in the flight deck with the hydraulics panel and the normal cockpit setup. So the hydraulics panel is located here, and you can see that we've got 4 pumps. We've got 2 engine-driven pumps and 2 electric pumps, and there's one of each for the hydraulic A system and one of each for the B system. Now normally you notice that the engine-driven pumps are in the on position, and this is absolutely normal that the pumps are always left on. The reason for that is that when you switch off an engine-driven pump, what you're doing is you're operating a solenoid-held valve that blocks the output for that pump. So when you switch the pump off, you're actually energizing the solenoid. So leaving either of these switches in the off position is energizing the solenoids and will impact their life. So these are normally left on. Obviously the pumps are not actually running until the engines are running, so there's no danger with having those pumps on. So you come to the flight deck like this, and the 2 electric pumps will be off, and if you look down here you'll see that the hydraulic pressures are low. So that's it. So the hydraulic pressures are shown here, and there's 1 gauge and 2 needles, A system, and the B system's hidden behind the A system needle. So when we come to the flight deck, as I say, the engine-driven pumps are on, the electric pumps are off. We would actually do the walk-around in that configuration with the hydraulics off. When the walk-around's complete and we're back in the flight deck, there's no need to switch the hydraulics on unless perhaps it's a particularly windy day, and then we might need to put hydraulics to the flight controls to act as a gust lock. If the aircraft sat in a strong tailwind, the wind can be blowing and potentially damaging the flight controls. So for a gust lock we can choose either hydraulic system A or B, and you will find that pilots will always choose hydraulic system B. I'll show you why in a moment, but let me just put that on, and as I put this on we'll go down and have a look at the hydraulic pressure. So we'll put on the B system electric pump, the low pressure light goes out. And if you look at the hydraulic pressure gauge, you see that the B systems come up to the normal operating temperature band there, around about 3000 psi. So the question is, why do we always use the B system and not the A system? It's because the A system also controls powers the nose wheel steering. And if we're up here in the flight deck, we don't know whether the ground crew have attached the tow bar, or indeed put the pin in for the steering bypass system. So as a safety precaution, we always use, if we have to, system B, and we will never put on system A until we've made contact with the ground crew and asked them to confirm that the tow bar is attached and the steering bypass pin is installed. When we hear those words from the ground crew, then we know it's safe to put the A system on as well. Now we've been down there, we know there's no tow bar attached, so if we want we can safely energize system A. So again, remove the switch, we'll expect to see the low pressure light go out, and if we come down to the gauge, you see that the A system pressure has also moved up to the green band there. And now we're ready for pushback. So that's the normal operation of that panel. After flight, when we park, set the parking brake, and we would switch off these 2 pumps as part of the shutdown checklist. And again, you see that the hydraulic pressure is reduced. Okay, so that covers the normal hydraulic systems, hydraulic system A and system B, but as we know that there's a 3rd system as well, the standby system. So let me talk about the standby system and how we activate that. So the standby hydraulics is all controlled here from the standby hydraulics and flight controls panel. And there are 5 ways to activate the standby pump, 3 of which we can do manually from here. So we can either move flight controls A to standby rudder, or flight controls B to standby rudder, or put the alternate flap switch to arm. Any three of those will engage the standby hydraulic pump. The two other ways, the automatic ways, one is if the aircraft is airborne with some flap and it senses a loss of System A or System B pressure. And the fifth way is if the force fight monitor detects a difference in pressures across the rudder PCU. So obviously the last two we can't demonstrate here, but the first three we can. So let's go up to the flight controls panel. Now, as it's been a while since the standby hydraulic pump has operated, what we'll expect to see that the first time we engage it is a very brief flash of the low pressure light, and then the standby rudder light, which is this one, will come on. So let's see if we get that. So flight control A, it's a guarded switch. We'll lift that up and we're going to move it to standby rudder. And as I say, we can expect to see a brief flash of low pressure and then standby rudder on. So let's do this now. And of course the low pressure light will extinguish. There we go. So you notice we got that brief flash of low pressure. That was as the pump was activated and then priming itself, and then came up to pressure. As it came up to pressure, the low pressure light went out. Standby rudder on because we put the standby rudder on, and the low pressure has gone out because that was saying that now, because we got no hydraulics, we've got standby hydraulic system is powering the rudder. You can also, I don't know if you pick up on the microphone here, but you can hear the noise, the background noise of the standby hydraulic pump running, which is another confidence check that it's going. Obviously in flight you wouldn't be able to hear that, but on the ground it's a good check. So I'm going to switch this off. The noise stops, the standby rudder light goes out, and the low pressure light illuminates. So we know that this one works. So let's try exactly the same with the hydraulics for System B. The only difference this time is that we won't get that flicker from the low pressure light because the pump's already primed, because it was only running a moment ago. So let's try this. Actually, we did get a very brief flicker, but we got the standby rudder on light, the low pressure light on the B system, if the caption was there, would show that that was now extinguished, and we can hear the noise, so that works. Again, we'll switch this off. And the last of the three is with the alternate flap switch. Red guarded switch because this action in flight is irreversible, because once we've extended leading edge devices in flight, they can't be retracted. But here on the ground, safe to do so. So again, we're going to move the alternate flap switch to arm, and what we expect to see here is simply the low pressure light flicker. This doesn't bring on standby rudder, so there won't be any change here, and it won't affect the low pressure lights down here. Again, we got the noise, we got a very, very brief flicker on the low light, so we know that this is brought on the standby hydraulic pump. And we can switch it off the same way as the others, just by switching it off. One last thing to mention on the hydraulic system. There is a PTU, power transfer unit, which is located in the E&E bay, and if the system detects that there's a low pressure on the B side, particularly for the engine-driven pump, it will use the A system pressure to move the B system quantity to be able to operate the auto slats and the leading edge devices. That's just an extra redundancy feature of the 737, so that we've got those devices in time. So there you go, that's it from me. A brief run through of the panels and controls of the hydraulic system A, B and the standby system. Thank you.